Hello everyone. Today we are going to see a video on video. A video is moving images with or without audio. There is analog video and digital video. But analog videos are no more used, so we will just look after digital videos. The use of digital techniques in video creation makes it a digital video. Different types of videos are SD, HD, Ultra HD or 4K videos and 3-dimensional video. We will also see something about video coding and compression. Digital systems have changed everything into digital. Upgrading analog video to digital video makes it easy to apply so many techniques on videos. We can apply different filters. We can add animation and graphics. An example of movie Bahubali, where you can see two images, one without graphics and one with graphics. We can apply augmented reality, where we can see by taking a picture of an image, we can create a animation around it. It's a real video where an animation gets added to the video. So as you can see, a lunar eclipse is shown. So this is a helpful augmentation of virtual world into the real world, which can be used in education. You might have seen news channels where videos of different places are put together in one scene. Also, you have seen cricket. So in that LBW you might have seen. So as you can see here, after a wicket is gone, we can see a Hawkeye prediction and the ball trajectory, which is actually not real, but it is been added to the video. This all happens only because of digital video. There are different types of videos: SD, HD, UHD, and so on. SD, standard definition, is a television system which uses a resolution that is not considered to be high or enhanced definition. The common SD resolution is 640 x 480 with 480 interlaced lines of resolution. So what's this 480? So it is the number of pixels in an image. So if you take an image of a flower here and we zoom it to a very small section, we can see it is made up of lots of points. Each point is nothing but a pixel, and that pixel has three different colors. If you are viewing a color image, that is R, G and B, red, green and blue. Depending on the intensity of this red, green and blue LEDs, you get different colors. So 480 is the number of lines, as you can see in this image, and 640 number of pixels in each line makes a SD resolution. Then there is high definition, HD. So HD resolution is 1280 x 720 with 720 interlaced lines of resolution. So as you can see, the difference between standard definition and high definition. There are 720 such lines. Each line consists of 1280 pixels. Full HD resolution is a little bit advanced, where there are 1080 interlaced lines and 1920 number of pixels in each line. There are some more types of videos like WUXGA or 2K or 4K. So you can see the resolutions are WUXGA has 1920 x 1200 lines. 2K has 2048 x 1440 number of lines, and 4K has 3840 into 2160 lines. There are 2160 lines in an image. So you can see the difference here: standard, high definition and 4K. So the clarity also increases. In standard the clarity is very less. As you can see, the lines are very far away. In HD, more clarity is there as the lines are very near. In 4K, the clarity will be very, very high as the lines are very, very near to each other. So by different resolutions, it means that how far you can sit and watch the TV. You can see the names 2K and 4K comes because of the number of pixels in each line. Just for thinking, as the number of lines and pixels goes on increasing, the size of the video also goes on increasing, and it requires more amount of memory. Just some facts about the TV. Standard definition televisions were the old televisions, CRT tubes. LED TVs which you see now are of two types, HD ready and HD. HD ready is having 720 lines and HD has 1080 lines. So it is having more resolution than HD ready. Cinema halls use 2K to 4K lines, so it's very high resolution. There are some televisions with UHD which are almost 4K. Unless and until you have a very big room, it is no use of getting a 4K TV. Simple HD TV is enough. What about the mobile phones then? Generally, a good mobile phone has 1280 cross 720 resolution, that is a HD resolution. Apple's Retina display has 1792 cross 828 resolution, which is little bit more than HD. iPhone 11 Pro, the costliest mobile, has 2436 cross 1125 resolution, which is actually a 2K. But maximum online video size we can see in mobile phones is 480p lines only because of the bandwidth limitation. I told you about the bandwidth and size of image, how it is related to the definitions. Let us take an example. When we say HD image, just a one frame of a video has 1280 cross 720 lines, which is nothing but 9,21,600 pixels. Each pixel requires 24 bits to represent a color image. When I multiply it with this, we will get nearly 2 megabytes of data. A minimum frames per second for humans to consider it as a video is 24 frames per second. So 2 MB into 24 uses 48 MB per second. If you're watching a 15 minutes video, you would require 43 GB of memory. Really? Wondering? Well, we don't require 43 GB. We see high definition movies, but still within 1 GB of a day. That's where video compression comes in handy. Video coding or compression is a very vast research area. Many researchers have already done a lot of work in this field. I will tell you only the simplest method of compressing the video: spatial compression and temporal compression. Spatial compression. It is nothing but reducing the pixel size within each frame by removing redundancies. Let's see an example of spatial compression of the image below. If this is an HD image, we have to send 48 MB data to display this image without any compression. But after compression, we only send 2 pixel values, 48 bytes, and some information about the area, how much area is covered by yellow pixels and how much area is covered by red pixels. That's all. If we compress it this way, just how many pixels this second image will use? Maybe less. Temporal compression means compressing over time period. Here, as we know, a video means continuous frames are displayed one after the other. Usually there won't be much changes in each frame, so we can reduce the frames sent. As you can see in the example, 3 frames are present in the video. Intermediate frame can be removed and made it as 2 frames. Then at the receiver end, they will just repeat the old frames to compensate the missing frames. Hence, by sending less frames, we save bandwidth. Let's see another example of temporal compression. Here, changes between the present and next frames are sent. That is called as motion compensation. Hence, at the receiver end, by seeing the motion vectors, they reconstruct the frames. As there are so many resolutions and compression techniques, how to maintain the standards universally is a challenge. If not maintained, our TV might not work with all cable channels. We would need one TV for each channel. So ITUT, International Telecommunication Union, coordinates the standards for telecommunication and information communication technology. So ITUT standards for video was initially MPEG 1 or H.261. Later they had MPEG 2, H.263, then 263 and so on. These standards tell which are the methods that can be used, which are the techniques that can be used while compression and coding. Every standard has more improved compression on video. At present, almost all systems use H.264. It is also called as high efficiency video coding. Recently, in July 2020, H.266 versatile video coding was released and it gives 50% more compression than HEVC. VVC was developed keeping 4K video streaming in mind. Hopefully, in near future we will be seeing 4K videos coming on our YouTube channels and our mobile phones. That's all about the video. I hope you learned something interesting about the video in this video. Thank you.